Good morning. Good morning, everyone. Can you hear me? All right. Welcome to NewOps Days. My name is Michael Kehoe. I'm a staff site reliability engineer at LinkedIn. And today I'm going to be talking about the next wave of reliability engineering. So today I want to do a quick introduction of who I am, what I do. We'll have a look at what site reliability engineering is and where it's taken us from and where it's taking us to. We'll then do a deep dive on the future of reliability engineering and what I see as the next wave of trends in the space. All right, so who am I? So I'm Michael Kehoe. I'm a staff site reliability engineer at LinkedIn, and I'm on a team called Production SRE. For those wondering, I do have somewhat of a funny accent. It's a little bit different to Andy's, but I am Australian, and I've lived in the US for nearly 5 years, actually, so I've lost most of my Australian twang. Before I joined LinkedIn, I used to be a network engineer at the University of Queensland. So I've seen operations from both a very application-driven side at LinkedIn, as well as a more infrastructure-based side at the University of Queensland. So as I said, I'm on this team called Production SRE at LinkedIn. Can I have my next slide, please? There we go. And my team has 4 key tenets. Disaster recovery, so planning what our disaster recovery strategy is and automating it. Incident response, defining the processes of how we respond to incidents. Thank you. Defining the processes of how we respond to incidents and then trying to automate that workflow as much as we possibly can. Visibility engineering, which is one of my favorite things, is making use of all the operational data that we have. So how many alerts are firing? How many incidents are we having? And rolling that up for our executives to make sense of and then to go and make forward-thinking strategic decisions on. And then finally, reliability principles, which is defining best practice and then automating it and evangelizing it throughout the company. Next slide, please. All right, so where have we come from? Next slide. All right, so traditionally, and we still even see this today, the traditional IT operations departments, complete departments silos, even between sysadmins and network engineers and then database engineers. They're all completely different silos that don't really work with each other. We have slow release cycles. It's still common to have release cycles of quarterly or every 6 months or every year. That's still common in some places. And as companies have adopted this, they've seen some benefits. We still have high toil workloads and poor operational visibility. And so we've started to evolve from this, and there's still a very wide spectrum of where we are as a community. But in the beginning of the 2000s, we started to see a move away from these traditional IT operations into site reliability engineering and DevOps. So what is reliability engineering? So the formal definition of site reliability engineering is from Ben Traynor-Sloss, who coined the role at Google in 2003. And it is, what happens when a software engineer is tasked with what used to be called operations? This is all sort of wordy to me, so I sort of rephrased it in a way that I liked. Next slide, please. Thank you. Which is helping product and engineering deliver the best experience possible from for the end user from an operations perspective. So the way I see this is from an operations perspective, helping the business run and deliver successful, reliable products. Next slide, please. So again, a lot of words. So what is really reliability engineering? So reliability engineering or site reliability engineering is a very specific, opinionated implementation of DevOps principles. And it is 2018, and I think we've moved past the SRE versus DevOps war. And we sort of understand what they are and where they fit together. So there's 5 key concepts for DevOps, the principles that they were born out of, which was reducing operational cycles, silos, sorry, and cycles, I guess, accepting failure as normal, implementing gradual, continual change, leveraging tooling and automation, and measuring everything. And as we've evolved, we've done some of these better than others, but let's just quickly walk through what these are. So reducing operational silos. So traditionally, there's been software engineers, they release their piece of code, and there's that meme that it worked fine on my desktop, it's operations problem now as soon as it's in production. And thankfully, we've moved away from this, where we now have shared responsibility for the code base and the operation of the code. And we now see developers being on call for the products that they actually push code to, which is a great step forward. Engineering and SRE use the same tools to manage the workflow of the product. So whether that be the development cycle, the release cycle, the monitoring, or even debugging, everyone has a standard set of tools available. And there is the expectation that developers and operations will work together and collaborate. Secondly, accept failure as normal. As we've evolved into containerize everything, we sort of learned somewhat to expect that failure is normal. For anyone who operates anything at scale, the pure math of it means that at any given point in time, you're either going to have a dead server, a dead hard drive, a faulty network switch. It's the pure mathematics of it. And so as you begin to scale your infrastructure, you've got to accept that failure is normal and really push to build resilient applications. So the key point here is to expect and embrace risk and build more resilient applications. Secondly, quantify failures via SLOs. So one of the key principles when SRE was first sort of evangelized was that we do not expect 100% uptime for everything. The amount of overhead that you have to put into your development cycles, your operation cycles, to actually achieve that is basically non-feasible for all except a small number of companies, mainly being financial institutions. And for the most part, people's internet connections are not going to be any more reliable than your application to actually measure the downtime. So we've learned that to quantify what failure is acceptable, so is 3 nines OK, is 4 nines OK, is 4.5 nines OK, and then measure that very specifically and understand that. And then finally, blameless postmortems, which I think is really important. Blameless postmortems have sort of helped build the collaboration that I mentioned previously and ensure that if we have an issue, we can get to the bottom of what happened, make sure everyone has action items, and no one feels begrudged at the end of the process. And it also encourages transparency, which is equally as important concept as reliability. Next slide, please. There we go. Implement gradual change. So I mentioned earlier that it wasn't uncommon to have these really long release cycles. At LinkedIn, it was probably 5 or 6 years ago, there were release cycles of like 3 months. And it would take weeks to go and merge code bases. And for any of those, for the newer companies, that's sort of crazy to think that you have these really long development cycles. So thankfully, we've moved towards continuous integration. We've also lowered the cost of failure. So if you roll out code once a week and there's a bug with it, you might be rolling back 1 feature instead of like 20 features over a 3 or 6 month time frame. And we've also learned to manage risk. So we see a lot of small deployments now, which is great. We've also seen a lot of feature gating, which is also really important to help manage the gradual rollout of code. Next slide, please. Leveraging tools and automations. So we keep hearing this term, automate yourself out of a job, which is all well and good. But what it really is automating the toil of your job away. As operations engineers, my time is much better spent ensuring that we can deploy faster, we have better monitoring than it is restarting some Java container. That's a really bad use of a professional IT person. So we've built tools and automation, and we still have a way to go on how we actually build those. But we are working towards reducing the human touch factor on our infrastructure. And as we see Kubernetes and Docker and Mesos, where we have orchestrated infrastructure, we'll continue moving towards the right on that direction. Next slide, please. Measuring everything. So it's really important to measure all aspects of systems. So whether that be the availability from the front end, middle tier errors, and also this sort of goes overlooked is incident statistics, which is something my team does. Looking at the time to detect, time to resolve, time between failure. These are all actually super useful metrics for building a story of what needs to be improved in your organization. So enough about the past. Where are we going? Next slide. Next slide, please. All right, and next slide. Harder without a clicker. Thanks. So building off these core DevOps principles, this is where we're more or less going. So we're firstly going to see increased agility in the way that we operate our code, and we also write our code. We accept failure as the new normal. We have ubiquitous automation. We observe everything in more depth. We actually ask the hard questions. And again, we measure everything, which I think out of the 5 DevOps principles is the one that generally industry is weakest at. So the next wave of reliability engineering. So let's look at some specifics. Next slide, please. All right. So firstly, the evolution of the network engineer. This role has been basically hasn't evolved for a very long time. And we're actually at the point of where the infrastructure has evolved, where we can do this. Secondly, again, we accept failure as a new normal, and we really look at evangelizing resiliency engineering. Thirdly, we have automation as a service. We sort of move away from scripts or small tools that automated some of our toil away, and we look at actually building platforms that help do this for us. Of course, cloud is king. Whether it be public cloud or private cloud, we are moving there, and we need to adapt some of our mindsets to expect that we don't own servers, we lease servers, at least as far as SREs are concerned. And then, of course, observe and measure. So let's dive into these. So dawn of the network reliability engineer. So Juniper posted this article. Thank you. Juniper posted this article at the beginning, at the late last year about the dawn of network reliability engineering and what it is. And so one of the things to really call out here is the infrastructure is evolving. Like even 6 years ago when I was doing network engineering, I was still manually SSHing into things and copy pasting configuration. And thankfully, I was able to write a really hacky Perl script and sort of make that suck a little bit less. But the system side and the application side have had things like Puppet and Ansible and Chef for so much longer, and it's only now that the network's sort of catching up, and we're starting to have a programmable network. So now we have network as code. So in the past couple of years, we've got OpenConfig and Yang models where we actually have a defined standard of how the network should be programmed. Instead of sort of setting and forgetting, we can actually have an intent-based network where if there are deviations in how configuration is applied, we can go and remediate that and not have sort of these one-offs that we'll never find. Thank you. The second one is continuous integration. So there are companies now who use GitHub to go and do pull requests for configuration on their network devices, which if you'd asked me 5 or 6 years ago, I would have thought it was crazy, but it actually really makes sense. These devices should be as programmable as the servers or the applications that run above them. And this is actually a really good way to ensure that the right thing is happening on our boxes and that we have the same level of accountability for that infrastructure. Thirdly, chaos engineering. It's all very well and good, sort of coming up with this really nice, redundant architecture. But how many times does it actually get tested, and how does your DR plan for your network actually get tested? And I've generally not seen a trend there, and it's something that we really need to start doing, and not expecting that we were perfect in our implementation of that redundant network design. More precise monitoring. We've lived in the days of SNMP for nearly forever. And for anyone who's really worked with it hands-on, it sucks. And we're finally to the point now where we have network telemetry, where we can stream logs off devices, we can stream events, we can stream monitoring off our devices, instead of polling them at these ridiculous rates to try and get metrics. And of course, continuous response. So if we do see an issue in the network, can we go and automatically respond to that and correct the issue? Next slide, please. So Greg Farrow from the Packet Pushers did this really good piece about this time last year about the evolution of the network, specifically towards intent-based networking, where we sort of move up from manual operations to scripts, to building out more visibility and visualization, and then doing analysis on that data that we have, and then building a reactive, predictive, self-operating network that is built off APIs and continuous response. And this is a really good indicator of where we should be going in the longer term, especially if you've got a network over maybe 30, 50 devices. You really need to start thinking about this because it does get really hard to sufficiently monitor how the infrastructure is running. Next slide, please. So accepting failure is normal. So in the past 12 months, there has been a huge push towards chaos engineering or resiliency engineering. And we basically expect that failure is going to happen now. So chaos engineering is the new black in the reliability space, and a number of large tech companies, Netflix, LinkedIn, et cetera, have spoke at length about their efforts to build more resilient applications by trying to break them in a controlled manner. And we've got companies like Gremlin who have popped up in the commercial space that are sort of really facilitating this for companies now, and gives people to test how their application responds to failure before it actually happens, and allows them to go and build a more resilient application before the large incident happens, not after it. Next slide, please. So when it comes to testing this, we need to do this on the data center level. We need to do it within the actual infrastructure. So taking the power out of a rack and seeing what happens, shutting down switch links, seeing what happens, and then also interrupting how the application runs, whether that be maxing out the CPU or introducing packet loss on the application, or even blocking API calls. This is all key ways to test how your platform responds to failure. Next slide, please. Automation as a service. So automation has been slowly evolving over the past couple of years. We've sort of gone from doing things manually to scripting them. And we're actually starting to get to a point where we have platforms. So you see sponsors like Rundeck here who have a really nice automation platform. definitely, at LinkedIn, we've evolved over the last couple of years where, we were deploying things manually to the point where we have orchestrated systems to go and shepherd the release process for us, to go and scale up and scale down our applications so that we don't have to. Equally, we also have auto remediation platforms. So if something does go wrong, we can go and get the system to go and try and remediate it, or go and do the investigation for us, and then at the end, give us a whole brain dump of what has happened before we get called. So by the time we do get interrupted, we do have to be engaged, we have as much possible information to go and act on the issue, which is great at 3 a.m. Next slide, please. So automation is expected. We really shouldn't be building applications that don't have automation or don't have hooks for automation. We really shouldn't be doing one-off scripts. If anyone has, uses libraries, you go and copy code from one person's desktop to another, and you don't have the right requirements, this really doesn't scale. We do need to have, if you do have scripts, have it in a very managed way where you can repeatedly build that code, or have platforms that can help do this. And of course, for the executive side, automation really helps to reduce the mean time to detect and the mean time to resolve on issues. The next trend is cloud is king, and this is very unsurprising. For the last couple of years, all we've heard about is cloud. But we do need to sort of pivot the way we think about running infrastructure. Next slide, please. All of our infrastructure is ephemeral now. So, people, still think that, hey, I own this host. No, you don't own this host. The business owns this host, and you sort of lease a container space on it now. And that really needs, we need to still continue to drive home that point that we need to build applications that will be able to move around the infrastructure, that will be able to be safely shut down and pop up somewhere else, that our firewall rules and our configuration policies can adjust. And then finally, the last new trend is a larger emphasis on observe and measure. And this goes back to the core DevOps principles. And we're not quite there yet on what I think we really should be doing as an industry. Next slide. Yep, thank you. So, within the reliability space, we've gone through the DevOps versus SRE war, and now we're in the observability versus monitoring war. But, really, if you want to define observability, it's an overarching set of, looking at the same data sets. But we have, logging, and we have incident data, and we have tracing. So it's maybe slightly more holistic. So if we go and look at a machine-driven triaging, we're seeing platforms like Zipkin and OpenTrace pop up where we can go and trace issues throughout our systems and get some insight into how the call graph is working. But we sort of leave it at that. The next iteration I see is using this data for the machine to actually work out what's happening and then make a recommendation to the operator of what's going on. All the data is there. We just need to build the platforms that can sort of interpret that and make the recommendations. The second item is doing advanced analysis on performance to drive infrastructure optimization. So people run stuff in containers, and they think it's great, and it is. But we don't really have a deeper look into how things are actually running, and am I getting the most optimal performance? And to do this is actually rather time-consuming, especially for a very sophisticated application. So we're beginning to see companies pop up like FastThread and FastGC, as well as I've definitely seen within LinkedIn more platforms to help evaluate the efficiency of an application and then make recommendations on how that can be improved. And then finally, we need to make use of all this great operational data. Number of incidents, time to detect, time to resolve, availability data, deployment velocity data. All this data gives us really great insight into how the business is running. And and how we can make strategic decisions going forward that improve the life of both developers and operations people. And once you aggregate this data and sort of filter through it, it is actually really meaningful for executives. And you can go and tune teams and organizations to make sure they are running to the best of their ability. Next slide, please, and the slide after. So key takeaways. Next slide, please. So again, where are we going? The scope and the role of network engineering will move more towards the DevOps reliability model, where they are writing code, where we are having a deeper look into monitoring and incident data. We accept failure as the new normal. We are testing our applications. We are doing resiliency engineering. We do expect that problems will occur, and we have contingency plans for them. Automation is ubiquitous. We're not running one-off scripts. We have platforms to help make sure that our hands are taken off the infrastructure. Fourthly, cloud is king. Whether it be private or public, we aren't owning hosts anymore. We are leasing space on them. We're moving our applications. And this actually helps build more resilient applications. And finally, observe and measure. We're taking all of that data. We're not just keeping it on dashboards. We're aggregating it. We're putting it into reports that we can go and use to make strategic business decisions that help improve how our teams run and how our applications run and how the business runs. And so with that, I think there's a couple of people with microphones running around.
Yeah.
If you have any questions.
So first of all, big round of applause for Michael for our first ever NewOps Day speaker. Yeah, really like that. It was a comprehensive look at things. I have a question for you.
Yeah.
So we're going to do like some Q&A after this talk, some Q&A after the Disney talk, which is coming up next. Since we got you here, one of the things we always wanted to add to a conference is more questions for the speaker. So kicking things off, operations is, everyone's going at 100%. There's never enough time for anything. So of all the things you talked about, if you had to prioritize and say, doing that was the best bang for our buck, or doing that was what put us off in the right direction or got us the time to do other things, where would you say, that's where I'd start on this path? So
in the words of a former SVP of engineering at LinkedIn, David Henke, you can't fix what you don't measure. Measuring how your teams are running, how your applications are running, the availability of those, that data helps form a strategy. So if you don't know, what's broken, you can't fix it. So I think having the data is the most valuable thing to start with, and then you can start planning out, what are your hotspots, what really needs to be addressed.
When you say have the data, what are the things you're looking for? When you're doing it right, what do you think? That's good data. So
for my team and how we do our visibility engineering, so we're looking at number of incidents per team, availability of services, mean time to detect, mean time to resolve, deployments to rollback ratio. They're very high-level operational data. Of course, we have employee voice surveys, which also tell a story from a sort of different perspective. But that data that I was mentioning really helps give a very high-level insight of how is this team doing, how is this product doing, and then from there you can start asking the deeper questions of all right, say if I have a really high rollback ratio, is something wrong in my testing or canary process? So having that high-level data allows you to ask questions that then can lead to fixing some other things.
Got it.
Cool. We have a question over there, but firstly, I want to ask you, Michael, just quickly. You talk about failure being an option. What does that actually look like for you in a real failure situation? When something fails, what actually happens in your world?
So actually, I'll plug my own blog post. So on InfoQ on Monday, I've actually got a deep dive of what LinkedIn's doing in this space. So look out for that then. But for us, we know that things are going to fail. We know that servers are going to fail. We know that top-of-rack switches are going to fail. We know that applications are going to have errors. So for us, we've got platforms where we can manipulate the host, so we can fill the disk, we can consume all the CPU, we can introduce network latency and packet loss on the host level. We also have this platform called Linked Out, where we can load a page, get the call graph, and then start failing down particular downstream API calls and see how the application responds. And from doing this, we've actually been able to refactor the application where we have like an 8x increase in throughput because we got rid of a whole lot of silly things that were slowing us down, like fixing timeouts or retries, like super simple ways to improve resiliency of applications. So that's what it tends to look like for us on a day-to-day basis at the moment.
Cool. Thank you.
Yeah. Kurt, go ahead.
I am standing behind the post over here. So you mentioned using automation to be hands-off the infrastructure and then trying to avoid one-off. Like, what's the NewOps perspective on the pod manifest file, the YAML file, which is kind of a one-off and directs the infrastructure? Is that something that ops views as good or bad? Is it like a run book now that's codified? Just curious on your thoughts there.
So for the most part, we try and get away from one-offs. I was actually looking at something last night where I saw things hard-coded for a fully qualified domain name. In the cloud space, in the Kehoe space, that doesn't work. It doesn't scale, especially when you get to LinkedIn scale. Things like having tagged configs where you can apply a configuration to a tag. And I don't use Kubernetes or AWS hands-on enough to sort of give a more detailed answer. But having those one-offs is OK to a certain extent, as long as you can automate where one host can swap out for another without too many problems. Generally, if you do have to do a one-off, you do want it to be written down in even if it is in Puppet, if it is in Chef. You do have that there so people aren't making actual changes on the box to apply something.
You mentioned that you felt that, I guess, network engineering or network infrastructure has evolved to the point now where network engineers can start to take more advantage of some of the things we've been doing in systems engineering. Yes. How do you feel that the database administrator community has... Do you feel like they're kind of on parity now with network engineering? Do you still feel like they're lagging behind?
I think it depends on what you're running, and I'm not going to name specific vendors. Some are better than others. We've definitely got stuff at LinkedIn, which is completely hands-on. We've also got stuff that is completely orchestrated, like source of truth databases that we can that are completely programmable. So there are definitely enough database products out there that are got a wide enough adoption where they might be a little bit further on than network engineering. I don't think the IETF is completely ratified OpenConfig or Yang, I can't remember which one it is, going through there at the moment. So the network space still has a little bit way to go. Obviously with Open Linux, we do have more programmable interfaces, and there have been a couple of RFCs gone through in the last year where we have now a defined streaming telemetry API as well, where we can get data off the devices. So we're getting closer. We're probably not at that point where we start to hit the exponential growth yet, but we are close, and it is coming.
Just quickly, up the front just first, and then we'll come to you in just a second. Sorry, thanks.
Yeah, so one of the things they mentioned early on, it's a big area of interest of mine, was they talked a lot about the increasing use of third-party components, right?
Yes.
So the big question is, with network, that's a really interesting question. How do you handle bringing in monitoring and understanding data from third parties? And does that involve explicit agreements, or do you just use APIs when they're available?
I don't have a good question. I don't have a good answer for that in the setting. Feel free to ping me on LinkedIn, and I can give you a better answer once I've thought about it a little bit more.
Cool.
Sorry. Gentleman at the back.
I just have a quick question about the automation. You mentioned the new trend is moving away from small tools and scripts and towards platform for automation. Have you noticed, or is your LinkedIn using any like a company-wide platform for automation? Like I noticed Netflix has something called Winston or other.
Yeah, so like LinkedIn has a very like a completely standardized deployment platform that we use, and we've built our own private cloud, so we've got pieces on top of that to do our orchestration. We also have like completely standardized monitoring. There's not 20 monitoring tools, there's one. We also have a standardized auto remediation platform as well. So anyone can plug into that. They can go and contribute to that. It's very smart and intelligent. So one of the key tenets we've got at LinkedIn, not to plug us too much, but it's our responsibility to build leverage within the company. Reinventing the wheel for your own sake is not productive, especially at scale. So we definitely push building these platforms and making them very open so people can contribute and get the most out of them.
Just on that, Michael, I've got another question. How much choice do you have in terms of choosing your own tooling? Pick your own automation tool, your own release tool, stuff like that. I mean, is that a empowered thing in your organization?
For the most part, we've got like one company standard. And so like Golang is a newer language at LinkedIn. And in the very beginning days, they had their own system. And we got the buy-in with the company to get all the Golang tooling into our build and deploy system, so that they can make the most of all the leverage that the company has built for Java and Python and C, whatever. So the short answer is no. For us, it's really about building something once, building it right, and building something that everyone can leverage and build on top of.
Thanks.
Hi, I'm just curious about your thoughts on golden.
Sorry, the light's right in my eyes.
No problem.
You're
so
fine.
Curious to hear your thoughts on golden signals, and often that will guide dev teams and kind of the supporting.
Sorry, what signals?
Golden signals.
Golden signals.
So I'd like to know, how much diversity do you see amongst the applications and systems that you work with in LinkedIn, and do you provide prescriptive guidance for teams?
So my team per se don't provide guidance. We definitely provide the data. So the visibility engineering work that I was talking about, like we build those reports every 3 months, and they go to all the engineering VPs. And then as an outcome, they have a meeting, they go through it, they ask questions of us about the data, and then from that, a set of action items are built. That might be what we call code yellows, where we sort of pause some of the product stuff, like new features, and we sort of deep dive more into the reliability or operability of the application. We do definitely see between different products, slightly different numbers. And when we do see that, we take action. Depending on what the actual signal is. As I said, availability is one of our sort of golden signals. What we call developer velocity is another one. So, how many deploys are they doing versus rollbacks or incidents? And so, those both two very important golden signals for us. And then, they do have slightly different action items. So, one might be a more in-depth, release process or canary process. One might be spending more time doing resiliency engineering.
So we have time for one more question, so I'm going to selfishly take it myself. What has this done to the organizational structure and the skill set? Can you talk about sort of it wasn't always this way, it's gotten better. How do you think, if you can imagine that time or another company, and then now kind of look at yourself now, what in terms of organizational structure and then in terms of the skills of the people in the operations domain, how has that shifted? Yeah,
so LinkedIn was one of the first non-Google adopters of the SRE mindset. So I think that goes back to 2007, 2008 when we started doing that at LinkedIn. As far as the organizational structure goes, SRE and engineering completely separate orgs. They still roll up to the SVP of engineering. But we are partners. SRE has the ability to block releases, to roll back releases, without any blowback. But we are there to help each other. one thing I did when I was working with an embedded product team is say at the beginning of the week, all right, what are you doing this week that I can help you with? So we don't have to, roll something back. We're not going to have an incident. Building those relationships, which I think goes to the first point of, reducing operational silos, is the key tenet of, the organizational structure. In terms of skill sets, our SREs, they have to do a coding test. They have to do a code review module. They still have to have sysadmin and network principles, as well as the ability to troubleshoot. So it's a very well-rounded set of skills. And of course, depending on what team you go into, you might have a more data-focused mindset, or a more coding-based mindset, or a more network-based mindset, depending on what you're doing.
All right, Michael Kehoe, everybody. Let's give him another round of applause. Thanks for coming.